Today's video is going to be over integration by parts. This is again another BC topic. This is your standard I-7, page 190 in your journal. The target for today is students will integrate a product function using integration by parts to determine the antiderivatives. So we've experienced some integrals. Let's say the integral of 2x e to the x squared dx. We've used u substitution where u is of the x squared, of course. We take the derivative of that and then divide it out so that 2x would disappear and we'd be left with that e to the u. But when we have an equation that looks maybe like this, u substitution is not going to work on a function like that because u would be our x. That's not going to really eliminate that x squared that's left over. So we have to jump to something else. That something else is this integration by parts. So we're dealing with a product. Integration by parts is like the inverse of the product rule. So anytime we want to integrate a product, we can do that inverse product rule, which is our integration by parts. So let's see where it is a formula, so let's see where it comes from. So again, we're going to start to be able to take integrals of functions that we can't normally take integrals of because u substitution doesn't work. If we think about our integration by parts, it's actually based on our product rule for derivatives. So if we take the derivative of u times v with respect to x, we get that product where we take the derivative of the first times the second plus the derivative of the second times the first. Now the one on your page is written kind of backwards, but really doesn't matter because we're adding. So you guys would probably see it more like this. So derivative of the first. Let's see if I can get this pen to work. So we would see derivative of the first times the second plus derivative of the second times the first. That is a u. Okay, you guys would normally write it like that. Again, it doesn't really matter the order we write it in. The outcome is the same. So if we think about it in short term, right there, this is u v prime plus v u prime. Same thing. Where both u and v are differential functions, continuous functions where we can actually take the derivative. So that means if u prime and v prime are also both continuous, we can integrate this function to get back to where we started because we know that the integral is the inverse operation of a derivative. So then we get something that looks like that. Okay, so if we integrate this, we'll get back to that u times v. We can take this and rewrite it and create a formula for us that will allow us to take the integral of functions like up at the top. Okay. And that formula is right there. So all we've really done is subtracted out the v du. We've subtracted out that piece right there to the other side to create this formula right here. And this formula allows us to do an integral of a product because that's exactly what that is, u times dv. So if we follow this formula, we start with u, we start with a dv, and then we use that to figure out all the pieces of the formula. And we're going to do some examples that show you how to do that. Okay, so we're always coming back to that formula for integration by parts. So make sure you highlight that formula. That's something that you'll need to remember. That's not something that's given on the AP exam. So let's actually look at a problem. If I can get to the page. Okay, so kind of going back to the problem that we started with. There's kind of a process that we do when we're trying to figure out the pieces of this formula. And the first thing we do is decide what our u is going to be. So in this case of our first example, our u is going to be x, which means our dv part is going to be everything else other than the x, so ex dx. Okay. And what we want to do to get, because we need to get u, we need to get v, we need to get the integral of v du. So I have this part right here. I need this part, the v, And then of course I need the du part, this part right here. So we're going to use what we split up to figure out those two pieces for that formula. So if I want the du, I need to take the derivative of the u term, which u is equal to x. So the first thing I do is take the derivative with respect to x of this equation, and that is terrible. Let's try that one more time. So, I might throw this across the room, so it might be a little while. Okay, so let's try it one more time. Let's move down here. So du with respect to x will give us 1. And if I solve that out, I get that du is equal to 1 dx. And that's what I needed for this part of the formula. So I'm done with that piece. I have that piece. Okay. Now for the v, if I want to, I have dv, the derivative of v. So if I want v, I'm going to integrate both sides of the equation. That's terrible. Well, we know the integral of v, or of dv, is just v. We're going to get v back. And the integral of e to the x, we know as e to the x. Okay, we're going to leave off the c for right now. We'll get that, or we'll bring that back in a minute. Let's see if I can move this stuff. Okay, maybe not. That's okay. So to set up our formula, if we set it up like this every time, where we put u equals and dv equals like that, we start right here to start filling in our formula, because our formula is u times v. So we're going to come this way. So u times v. So we can separate this as x e to the x minus the integral, and this is just from the formula. And then we go from here, our v du. So e to the x times 1 dx. Okay. So we're not really using that first part or that second part up at the top right corner. We're using that path to create and put in our equation. And if I simplify this, I'm going to give myself some room. If I simplify this, x e to the x can state that minus the integral. Well, e to the x times 1 is just e to the x. If I want to simplify it, dx. Which means I get x e to the x. And now I have something that I can definitely integrate, the integral of e to the x, which means I get minus e to the x. And then here's where we're going to knock on our plus c at the end. Okay, and that right there represents the integral of x e to the x dx. So kind of undoing the product rule. Okay, so if we look at the second problem, I'm going to choose my u to be the natural log of x. That means my dv is everything else. Okay. So I'm going to take the integral of, I'm going to take the derivative of the first one. So I'm going to get du over dx equals the natural log x derivative winds up being 1 over x. So if I solve for du, I'm going to get 1 over x dx. And I'm always going to be multiplying by that dx. Kind of like in u substitution, we always did that certain thing as a result of this process. So we can start going straight there if we want. Okay. The second one, I'm going to integrate. So I'm always taking the derivative of the first column and always integrating the second column. So I'm going to get back to v equals. And then, of course, the integral of x squared gives us 1/3 x to the third power. Okay. So to go fill in, remember I'm starting in this corner and I'm coming down and multiplying. That's my u times my v. So natural log of x times 1/3 x cubed minus the integral. And then I'm going with my v, my 1/3 x cubed, let's see if I can fit this in, times 1 over x dx. Perfect amount of room. So I want to spend some time kind of cleaning this up and simplifying this down, putting everything where it goes before I decide to do the last thing, which is to integrate that last piece. Okay, I know you guys have more room than I do on here, so if I want to simplify it, I'm going to put that 1/3 x cubed in the front. Remember, we like our transcendental functions in the end. So 1/3 x cubed, natural log of x, and that way we don't multiply that x cubed times that x in the natural log. And then here, I'm going to pull out the 1/3. It's a coefficient. Remember, we do that often. And then x cubed times 1/x is going to get us back to x squared dx. And again, that's something we can integrate, so I'm going to do that. So just bring down that 1/3 x cubed, natural log of x minus the coefficient of 1/3. And then the integral of x squared gets us back to 1/3 x cubed. And then, of course, plus c. I'm just going to simplify this out really quickly. To combine those 1/3 to become a 1/9. And there we go. We have the antiderivative of a product that doesn't use our product rule. Okay. Let's go to another example. The example at the top. Okay. Write small if you need more room. Go ahead and use a Post-it note, something like that, because this one might take some room. So if I decide to use this one, I'm going to say that u is my x squared. That means my dv is everything else. Okay. So then my du, it's going to equal 2x dx. And remember, I'm going to start going straight there because I'm always going to be multiplying by that dx as part of the derivative. Okay, because I want the du alone. And then my v, well, the integral of both sides, the integral of sine being our negative cosine. Okay. I'm starting with that u in that corner, so here to here. So x squared times our negative cosine x minus the integral of negative cosine x times 2x dx. Okay. Well, that's a mess. I'm going to clean this up really quickly before I integrate. I always want to kind of do that just to get rid of some parentheses to make it a little bit more sense. That negative and negative is going to become a positive, and I'm going to integrate. I'm going to put that 2x in front. Okay. I think it's something like that. The problem with this one is the fact that this is still not something that's integratable, which means I'd have to use integration by parts again. This is what we call a repeated integration by parts problem. So I'm going to do integration by parts, and I'm going to change colors to show you the second integration by parts for that 2x cosine x. Okay, so again, my u, I'm going to choose my u. Let me... So I'm going to choose my u to be my 2x, my dv to be my cosine x dx. Okay. So I'm going to take the derivative of the first one, so I'm going to get du equals 2 dx, and that's nice because my x is going to kind of cancel out. That's going to be really, really nice because I'm not going to have to really do integration by parts again because that 2x from the previous one was a problem. And if we integrate the first part, we get v equals sine of x dx. Okay. So again, what I'm doing is I'm coming up here and I'm bringing down the piece here. So plus. And I'm about to start my integration by parts for the second time. So let me actually change one thing really quickly so we can kind of keep it color-coded. Because this first part right here, that looks like a approximation sign. That first part right here was from our first integration by parts. Plus. Okay, now the integration by parts for the second piece is going to be in red. So what I'm doing is I'm starting here again and coming down. So 2x sine of x if you go into the room of the other problem, don't worry about it because we're going to have to move that problem anyway for tomorrow or for Monday. So 2x sine x and then minus the integral of sine, sorry, that should not be a dx anymore. Right there. Sine of x times 2 dx. Okay. I'm going to take some time to simplify it, so I'm going to do it all in red now. These can get pretty long depending on how many times you have to take the integral. So I'm going to pull out that 2 as a coefficient. And now I'm ready to integrate that last piece. I'm just bringing down the pieces that I don't have to worry about that are already done. And then the integral of sine gives us negative cosine, so that's going to turn that into a plus. Cosine x, and then there is my plus c. Okay, so we're going to stop there for the video, and what I want you to do on Monday is come in with any questions that you have over those 3 problems, and then we'll do that last problem together. Like I said, if you ran into the room with that last problem, don't worry because I'm going to move it for Monday. Okay, if you have any questions, come and see me.